Thanks for coming for the final session, saving the best till last. This is how to build Spring services for cloud-native platforms using the Open Service Broker API. So for some introductions.
Hi, everybody. My name's Sam Gunaratne. I'm an engineer working for Pivotal. I work on a Cloud Foundry Foundation team. We work on services for the platform and specifically implementing the Open Service Broker API in Cloud Foundry.
And I'm McNeeney. I'm the project lead for the Cloud Foundry Services API team and a member of the Open Service Broker API Project Management Committee. And we'll talk all about that API spec in a little bit. OK, so the agenda. So we're first going to talk about why we need services and what they actually are. Then we'll talk about what are service brokers. Then a quick overview and history of the Open Service Broker API, followed by a live demo where Sam's going to build a Spring Service Broker in front of your very eyes, and then we're going to use it from both Cloud Foundry and Kubernetes and kind of show you the full lifecycle management of a service instance. OK, so to set the scene, I'm going to talk about why do we need services. This is all pretty high level, so we'll fly through this quite quickly. There's 3 rules. Firstly, applications have dependencies. It doesn't matter if you're lifting a legacy application onto some kind of public or private cloud, or you're writing some awesome new fancy 12-factor app. We know that these things need backing services, and state is really hard to manage in your application. It doesn't matter, like when we say services, we don't just mean databases and typical like storage. We mean anything from configuration services, things like service registries, service discovery. A lot of things that your applications, we want to abstract away from your applications and make them easy to run on like any environment. All right, so that's rule 1. Rule 2 is not all development time is spent equal. So if you imagine like you have a user value line, things that actually benefit your customers and things that don't. Things like innovating some awesome new ideas, some new features into your app. Your customers love that. Fixing bugs, making your apps more reliable, increasing the uptime. These are all things that actually kind of give like real, like tangible value to your products. Things that don't are things like reinventing the wheel, writing boilerplate code over and over again, basic building blocks, just doing all the stuff which someone's already done 100 times before. This is not worth your time. Which leads us on to rule number 3, which is leave it to the experts. There's people who spend all day, every day, optimizing your MySQL database, fine-tuning it, making it better. Let them do it. They're experts. You focus on your application and actually providing some real value to your users. OK, that's it. That's the scene set.
Awesome. So on to brokers. So imagine we have a platform, and this platform could be anything. It could be a Cloud Foundry platform. It could be Kubernetes. It could be something custom, running Docker. And you host your applications in there. And for the reasons Matt talked about, you want those applications to be bound to backing services. So how do you get access to those services? And that's where the service broker model comes in. So service brokers allow the platform to delegate like the responsibility of managing the lifecycle of those services. So the platform doesn't have to worry about it. That's the broker's responsibility. So imagine we have a developer for a platform, and they want to create a service instance. The platform proxies that request to the broker, and then the broker can go and just make that so. But what does that like really mean? Well, there's all sorts of brokers providing all sorts of services, so it depends on the broker. So typical use cases, Matt said, like state is a really hard thing to get right. Have a backing service. So your service could be like a database. And when you do say create service, that could go and provision you some infrastructure somewhere and install a database on it. But not necessarily. It could be that there's a multi-tenant database, and you just get a multi-tenant database installed, and you just get some namespace within that. But it could be something else, like non-database related. It could be service discovery, so like the Spring Cloud Services Eureka service. Maybe you want your applications all to register there. You could have a service for that. And it could be, as we saw earlier, Google providing like fully managed services. So something like Spanner. Maybe your applications want access to Spanner. So we have our applications in the platform, and we have our services managed by the broker. Next thing the user wants to do is bind the services to their applications. So the platform goes to the broker, receives the credentials, and then injects them into the application. So in Cloud Foundry's case, this is the VCAP services like paradigm, where the credentials are injected as environment variables. And then the applications can talk directly to the service instances.
Awesome. Thanks. So a quick bit of history about the Open Service Broker API. So this originally started out as the Cloud Foundry Service Broker API. It was part of kind of the core Cloud Foundry cloud controller for quite a few years. But late last year, in December 2016, we made the decision to transform this into the Open Service Broker API. The good news was that it was totally compliant with the previous service broker API, so you didn't have to rewrite your service brokers. And that's a key kind of part of the goals of this project. We want service providers, ISVs, to be able to create their services once and offer them to as many platforms as possible. That way, as we saw earlier, like rule number 3, leave it to the experts, they can focus on making their service better, not worrying about writing 10 different integrations for all the different customers that they want to provide their service to. So it's basically a consistent language that platforms and brokers can talk to each other using. So platforms implementing this today are things like Cloud Foundry and Kubernetes. And we have like a plethora of service brokers today, from everything, as we saw earlier, from configuration services, databases, and everything in between, who can all, you can plug into any platform, no matter where you are. It's still managed under the Cloud Foundry Foundation, but now has its own project management committee who is steering the direction of that project. So you can see that that's like the marketing message. We allow software vendors a single way to deliver their services to apps and containers. And all these awesome companies are on the project management committee implementing it for their own platforms. We have Kubernetes, Cloud Foundry, IBM's Bluemix, Red Hat's OpenShift, and many, many more. OK, so getting more technical, let's talk about, interestingly, how do I actually go and build one of these things tomorrow? So the good news is there's only 3 endpoints you actually have to offer. The first one is as a broker, you have to say, hey, these are the services that I provide to you. And that's for the catalog endpoint. So the best way to think about this is just a big kind of static blob of all the data describing everything that your broker has to offer. So one service broker can offer 1 or more services, and each service is built up of plans. So an easy way to think of this is, let's say your service was a MySQL database. You could have 3 plans, small, medium, and large, and they could correspond to anything. It could be like the number of CPU nodes you get, the amount of memory. It's entirely up to the service broker, and platforms are responsible for kind of providing that information in a nice, intuitive way to developers using their platform. The second is, okay, service broker, I know what you can give me. Now give me one of those things. I've chosen the small plan. I know what I want. That's just a simple post call to the service broker. This can happen synchronously or asynchronously. As Sam mentioned, this doesn't necessarily have to go and spin up a VM. It could be using some pre-provisioned resource. But at some point, you get back, and the service broker says, all right, you're good to go. Your service instance is ready. And finally, we have an API number 3, which is give me access to this service instance. So again, this is called a service binding. There's multiple ways that you can implement a service binding. The most common is you just give back a set of credentials and a URI endpoint of where you can actually access that service instance you've created. But there are other options for this, right? So you can have there's a type of binding called a volume mount. So you can go and mount a remote volume into your application or container. You also have root services where you can intercept all of the traffic going to your app or container and do some clever authorization, checking headers, whatever you want to do. And that's it. So it's just 3 very simple endpoints. You can put this in front of an application you already have running, something you want to offer out as a software as a service. OK, and now the fun bit, which is the demo, which on this patchy Wi-Fi will be interesting, but hopefully it'll go OK. To kind of outline what we're going to show you, I'm Sam. That's Sam. He's firstly going to build a service broker using Spring and push that to a Cloud Foundry environment. Once we've done that, we're going to have 2 kind of side-by-side terminal windows, one on a Cloud Foundry, one running against Kubernetes, in this case Minikube. And we're going to kind of go through the full life cycle kind of simultaneously. So the first thing, as we know, we need to register the service broker with that platform. That'll add it to the Cloud Foundry marketplace and create a new resource in Kubernetes. Second part of the demo, we will create a new service instance. Again, we don't care where that is. We don't care what it is. It can be running anywhere, any cloud. We just create something, and we get told it's OK and it's ready to go. And finally, we're going to ask to get access to those service instances that we've just created. And what that's going to look like is in Cloud Foundry, we're going to create a service key, which will basically show us in this case, the URI and the credentials to access the service we've created. And in Kubernetes, because there's already a concept of secrets, we'll actually just go and create a new secret with all that information. And that's it. So over to Sam.
Ooh, OK. Here we go. Let's wait for IntelliJ to catch up.
Like all good demos, this always happens for the first time. All right, if it doesn't start up, we can just we'll just jump straight to the terminal bit.
Let's evaluate IntelliJ.
We're just building up the anticipation, really.
Yeah, I know.
Good tactic.
OK, I remember this. OK, here we go. OK, awesome. So what we've got here is a Spring Boot application. And since we don't have a huge amount of time, what we've done is we've got like a service that we're going to offer. So I've got an idea. I'm going to create the world's best/simplest database. So if we have a look at this class, just stores an integer and allows me to set that value. I think it's going to be pretty good. It's going to be awesome.
You're not leaving it to the experts, though, Sam.
That's true. So what I'm going to do, so I've got this repository class, and this is just storing a map of identifiers for both stores. So imagine this is like a multi-tenant database that I'm creating. And I've just got a bunch of functions here: create a store, add to the store, and retrieve from the store. So next, we have like an abstraction for the users. So like in this very simple model, again, it's just a map of the IDs to a particular user. And we have the ability to create users and delete users and authenticate users. And then finally, we just have a controller here that just has our endpoints to allow us to get and set that value. So this is our service. And this could be anything. The question now is, how do I make this conform to like the Open Service Broker API so that we can use it in Cloud Foundry and Kubernetes? So as Matt said, the first thing we need to do is define catalog. So I've just used a snippet there, because this is just static metadata, as Matt said. And this is just the definition of our service and the definition of our plan. So yeah, just JSON, one service, one plan. Super simple. So next, if we head back over here, I'm going to create a new service instance class. And so this is all powered by, so if we look at our POM, what I've pulled in is a framework that the Spring team provide, which is the Spring Cloud Foundry Service Broker framework. And this is just provides you like nice Java mappings for the Open Service Broker API. So we head back to our service instance. Going to define this as a service and implement service instance binding. Service instance service, and implement the method. So this defines Java methods for all of the like management for a service instance. So we have create, delete, update, which is optional, which we're not going to implement, and get last operation, as Matt said, that's for sync 8. So what we're going to do is auto-wire in a new repository class. And then we're going to delegate out to call the create store function. So we need to provide an ID. This is like the mapping, if you remember back to our map. So thankfully, as part of the Open Service Broker spec, it defines that the platform decides what the ID is. So our request here that comes in has a bunch of functions. And one of the things we can do is get the service instance ID that the platform has generated. So that's done. And now we just need to create a new response. Oh, not that one. That one. And this is just like a blanket response. It just says, yes, OK, that has been created. So we're going to do something very similar for delete. Just change these. Awesome. OK, so that's our basic instance. So next, we have to implement the service binding. Use proper casing there. OK, cool. So going to do the same sort of thing here. Service instance binding response, and implement those two methods. So this is a little simpler. We only have the options to create and delete a service binding. So here, yeah, we want to get access to our service, so get the credentials to return back to the platform so they can be placed inside the application. So we're going to auto-wire in our access class. And we're going to ask our access to create us a new user for the same request. So now we're going to return back to the platform. But this time, we want to return it with something. So we want to return with some credentials. So we back from this, not soap binding. Back from this, we get a user class, which is it's just got a username and password. And from here, we can just turn the username and password and the URI from that credential into a map so that we can return it as part of this API. And you can see here that the URL we've provided is like URL specific for the instance so that those credentials work. So the application just can grab that URL and connect with the credentials and exclusions.
I think one of the useful things to point out there is that this means you can give out like the credentials to access the same service instance multiple times, but all those credentials can be unique. So let's say you have multiple applications talking to one database, and you want to take one database out of service, one application out of service. You can do that, and you only have to revoke that single credential. You don't have to go and kind of redeploy all your applications, changing the credentials across them all for security reasons. You kind of have you can manage that in a much more kind of seamless way.
Awesome. And then the final thing we need to do is for the delete user, just ask for that user to be deleted. OK, awesome. So this is our very simple broker. It's just showing you how you can, what you need to implement to enable the Open Service Broker API compatibility. So if we head to here, we're just going to build that. We're not going to push it to CF since our Wi-Fi wasn't working, but we've pre-pushed, so it's fine. Let's hope teammate holds up. OK, so let's build. So we can see here, if we look at the applications, we've got this broker deployed to Cloud Foundry. So it just so happens to be that this broker is deployed to CF. It doesn't have to be. It could be deployed anywhere, as long as the platform has access to it. OK, on to the exciting bit.
Yeah, so on the left-hand side, in the white box, that's the Kubernetes environment. On the right-hand side, in the darker box, that's the Cloud Foundry environment. As you said before, we're going to go through the full kind of service instance lifecycle management side by side, so you can kind of see the experiences in both CF and Kubernetes today, and kind of showing the power of the Open Service Broker spec, how they're both talking the same language to this service broker that Sam's just written.
Cool. And we're just going to run some demo scripts. This is just to save us typing. These are still making the actual calls. OK, you ready?
I'm ready.
All right.
So ready. Yeah.
I'll go first. So first of all, Cloud Foundry side of things, what we're going to do is we're going to check out. Can everybody see that OK? OK, awesome. We're just going to check out the marketplace. So you can see here we've got no services in RCF right now.
Yeah, and to do the same thing in Kubernetes, I'm running the CF marketplace. That was a good start, wasn't it? OK. And to do the same thing in Kubernetes, I can get the cluster service broker resource. This is there's a project called the Service Catalog project, which is responsible for implementing the platform side of the service broker spec in Kubernetes. So we're making use of that project, which has just gone into beta, which is awesome. I can get any cluster service brokers that are already registered into my platform. And as we can see, I'm in the same state as the Cloud Foundry environment right now. We don't have anything ready to go.
All right, onwards. So next, we're going to go and create a service broker. So this is registering the service broker into CF. So this goes and hits the V2 catalog and goes and gets all that metadata and puts it into the platform. So we're just going to create that now using the username and password of the actual broker itself, not the service. Let's go and do that. And then in CF, by default, all services are disabled after registration. So we're just going to go and enable them for the entire foundation. All right.
Cool. So to do the same thing in Kubernetes, I obviously need a YAML file. So this is going to be my broker YAML. As you can see here, it's using that service catalog API extension. We're going to call it Spring Broker demo, just like in Cloud Foundry. And instead of providing the kind of basic auth username and password to talk to the broker over the CLI, I'm just going to reference a Kubernetes secret that I created. So I'm going to go create that broker YAML, and we can see we should be good to go.
Good timing. OK, so now we're going to look at the marketplace in CF, and we should see that our service has been registered. You can see it's got one plan. It's a simple plan.
And likewise, if I go and get my cluster service brokers now, you can see here it is, the Spring Broker demo. But that's the service broker, not the service that it's exposing. So when I have to go get a different resource, we can't use the name service here because service is already a thing in Kubernetes. So we call this a service class. So if I get my cluster service classes, we can see here, like in Cloud Foundry, I have my Spring Broker service. Finally, I can get my service plans, which should just give me my simple plan.
OK, you guessed it. We're going to go create a service instance. So we're going to specify the service name, the plan name, and then an arbitrary name of the instance called my service. So this is going to go and hit the create service implementation that we made earlier. And then if we go and look at the services available, we should see that we have our service. Cool.
Awesome. Kubernetes, we're going to have another YAML file. This time it's going to be our kind of our service instance YAML. I'm going to give it the name my service. And you can see here in the spec object, I had to say the actual what service name and what plan name I want to create my resource using. So we're going to choose the simple plan. If I go and create that resource, for this demo it's happening synchronously, so you don't have to wait. And if I actually go and look at my service instances now, we can see here I have my service instance called my service created. And if I scroll down, see the message was this instance was provisioned successfully. So we should be ready to go.
Awesome. So now Cloud Foundry said we're going to create a service key. So in CF, there are two types of service bindings. The normal binding you use is a binding to an application. But for the purposes of this demo, we're just going to create a service key. And what that is still a binding that's returned from the broker into the platform. It's just not associated with an application. It's just stored in the platform. So create that key. And then if we go and view it, we can see that we have the password URL and username for our service instance.
And likewise in Kubernetes, one more YAML file, this time for the binding. Because Kubernetes, as I kind of mentioned earlier, already has this concept of secrets, we're actually going to use this binding and get that URL, password, and username and inject that into a Kubernetes secret that we can then go and check out in our namespace. And obviously, any containers you have running on your pods can just automatically go and pull that out into their environment. So if I create that resource, we should see it's created. And if I now go and get my service bindings, we should see that the message down there is an injected bind result, and we can see there it's ready to be used. But obviously, we can't see any useful information in there. We have to go and get the secrets in our development namespace. You can see here 23 seconds ago, we created our MySecret token. And if I go look at that, then we can see at the top here in the data, we have our password, our URL, and our username. The reason they look different to in Cloud Foundry is because these are all encoded by default in base 64. And that's it. I think now all I have to do is clean some stuff up. So again, this will hit those API endpoints we implemented on the broker. But we can delete the service binding in both sides, and then delete the service instance in both sides. And we should have nothing left. All right, okay. Success.
Thank you very much. So what we showed you was building one broker, registering it with multiple platforms, showing the Open Service Broker API. I mean, it's such a new project. It's only been around for just over a year. Service Catalog folks have done an awesome job. The fact that existing brokers, as long as they're built to the V2 specification, will just work with Kubernetes is totally awesome. So there's if you want to know more, there's a weekly call that happens as part of the working group. There's 10 minutes at the beginning of every call to discuss community interests. So if you're building platforms or brokers, I'd be really interested to hear from you.
Yeah, we've got some really interesting discussions going on now. We're talking about how we can implement a better authentication flow to brokers, things like using something like OAuth instead of basic auth, how brokers can kind of expose actions that you could do on a service instance. So let's say for a database, you could kind of, through the service broker, say, hey, give me a backup or restore my database to some prior known state. And we're kind of doing that in a very programmatic way. So again, it doesn't matter what platform you're running or where your service broker lives, but we're kind of exposing that as in a generic actions concept. And then some other cool things like asynchronous bindings, and a whole lot more. So check out there's a roadmap on the Open Service Broker API website, or just jump into the call, and we'd love to kind of hear your feedback, both from platform side and service broker side.
Thank you very much.